Let me share some observations, tricks and doubts from 5 years of creating Khan-style videos. I have a YouTube channel with mathematics and computer science lectures, if you will, Khan-style videos actually. In September 2012 I started a MOOC on Udacity, which is still up and running. And recently, together with Robin Boll, a student from Saarland University, I started a website that's called Capira. I want to share with you some collected experience from these experiments, if you will. First of all, what I noticed, typical textbooks and old-style lectures and lecture recordings look pretty much quote-unquote hostile. I try to describe in a picture, to represent in a picture what the student's impression is, what you seem to see when you are sitting in such a lecture. And I guess in the terms of Marshall McLuhan, what is the message that is actually being sent by such a lecture? The message that's being sent is, look at what I can do. It's not so much concerned with learning and teaching, just demonstrating the lecturer's ability. There are styles that are somewhat more friendly. They look as though they are somewhat more friendly. One of these styles is what I would call a recipe. There is an equation and you have to plug in values. But is this equation valid in the case at hand? What if you forget one of these steps? This value, does it go in here? Does it go in there? So here too there is a hidden message behind this type of teaching. It's do what I say and everything is okay. Don't think about it, just do what I say. There is a second type of lectures, of textbooks that seems to be friendly, but actually it isn't. Recently, the Higgs boson was officially discovered, and when you look at newspaper reports on the Higgs boson, what does it do? Many reporters write it's like cosmic molasses, but that's a bad idea. Once you think about the Higgs boson as cosmic molasses, you stifle your mental progress, your progress of understanding. It is not like molasses. I describe it a little more in the paper. Life isn't that simple as these superficial explanations seem to be saying. The hidden message behind such an explanation would be, don't think too hard, it doesn't matter anyway. And now, Khan-style lectures, Khan-style videos I should be saying, Khan-style videos. They look friendly, and if you really manage to avoid this recipe style and this superficial style, they may actually be better than the classic hostile type of explanations. And I guess the message here is like, this is for pedestrians. Let's together try to figure out how things work. In those years of teaching in that style, I came up with some principles, if you will. For instance, I always try to really honestly answer what this is good for. In mathematics, for instance, we have stuff like partial fractions or the Laplace transform. And if you're honest, you have to say to the students, okay, you may need that in 2 years from now. You may need it, depending on your specialization, for instance. I really try to be honest. These principles are more connected to what you actually can do. For instance, I try to use lots of diagrams to quote-unquote prove things. I do not like mathematical proofs. I really want my students to be able to have an intuitive understanding of what's happening there. I'm teaching in an engineer's course, so I want my students to think like engineers. 0 divided by infinity. This term goes to 42, this term tends to 13. What's going to happen? I do not want them to think in terms of epsilons and deltas. I want them to have an idea of the bigger scope of things, so to speak. How do these curves look like? What's going to happen when this variable tends to that value? Stuff like that. In the first weeks, I try to be concrete. I'm not writing A plus B plus C. I'm writing 13 plus 42 plus 100, stuff like that, using concrete numbers. And I try to use symmetries. For instance, in physics, you have the linear momentum and the angular momentum. That's nice to do in a table. What's similar between linear momentum and angular momentum, and what's different? Stuff like that. Symmetries and analogies. A lot of times in mathematics, one tends to just give that recipe. What's the cross product of two vectors? write down the equation, and that's it. I don't like that style. I really want my students to have an idea why it's this sort of easy equation, but why that is the case. For engineers, I really prefer intuitive over elegant. In mathematics, in a mathematics course, you would probably aim at elegance. You would try to find the shortest proof or something like that. For engineers, I really try to instill intuition. How do these different parts of the machinery work together? Not something that cuts straight through the machinery with an immediate result, something that's elegant in terms of mathematics. And I try to provide models, ideas, methods that reach further, not just an explanation for this circumstance at hand, but something that reaches further, something that you can generalize, something that you can build on. Some tips and tricks that I learned. There's lots of graphics design techniques out there that we can borrow for this type of videos. For instance, in comics, speed lines. Something moves, it gets speed lines, for instance. Something is bright, something is in the foreground, something is in the background. The language of comics has tons of ideas to help us there with graphics design. Simple stuff, just look at comics. And information visualization too, of course. Whenever you do some sort of diagram, be it a histogram, be it a complex machine, the techniques of information visualization do help. And of course, this is the Bible for what we are doing, Richard Meyer's multimedia learning. Some technical tricks. We saw that for the MOOC production process at EPFL, sometimes a prompter is being used so that you can, as a lecturer, read off the screen in front of the camera. You can do that far more easily. You just write in a different color on that same screen that you're using to produce your handwriting. You're writing up front in a different color, and later in the video production process take out that color, erase that color. Far easier than this complex optical setup. The most important lesson that I learned concerns how to record videos. First of all, I really like to improvise, like a jazz musician. Tons of preparation, days of preparation maybe, years of preparation, but then it's improvisation. It's not highly prescribed, there is no script, it's improvised. Do that in front of a live audience. I've got 2,500 videos online on YouTube. Almost all of them are live recordings, otherwise I would never have managed to get to that number. I'm doing this really cheaply, so this is has been my setup for the past years. It's an old-fashioned Windows tablet PC, so a regular Windows notebook with that Wacom-style digitizer built in. That's what I used for these 2,500 videos. Next semester I'm going to switch to Windows 8 tablet PC, a 15-inch Windows 8 tablet PC. I would not invest too much money into the production quality, but rather think about explanations. Some caveats that I learned about. First of all, if videos are too simple, and they tend to be simple, because you want your students to like those videos, and you want everybody on YouTube and on the world to like those videos. They tend to be too simple. These explanations tend to be too simple. That is tricky. Whenever you want your students or the people on the outside to learn something, they have to invest mental effort. This is a term coined by Salomon years ago, decades ago even. And the students have to overcome difficulties, otherwise they won't learn. There's studies on that, in particular by Bjork, for instance, under the heading of desirable difficulties. There is no learning without difficulties. That's tricky when we're doing videos. Often we're trying to make things too simple, too smooth. Some other caveats. Derek Muller has researched into misunderstandings. When the student starts out with a misunderstanding, for instance, concerning the nature of forces in physics, when the student starts out with a misunderstanding, then watches a very smoothly produced video, the students may think, oh, I understood it, great video, but actually you find out that the misunderstanding remained. These things do happen, so be careful about this smooth style of videos. One has to address misunderstandings, potential misunderstandings. Related to that is this star professor effect reported by Carpenter et al. smooth, highly polished lecture may give the illusion that one has learned something, but one actually didn't learn anything more than with a poor, quote-unquote, poor lecture. And this one is the classic, the Dr. Fox effect. Now, Tuflin asked an actor to present a lecture at a conference, and everybody in the conference thought, okay, this is a great lecturer, somebody who really knows what he's talking about. It was just an actor telling nonsense. So be careful about these things. A polished presentation does not mean that anybody has learned something. So I'm very careful about these numbers. What does this mean? So and so many thousand persons clicked on that video. Is it good? Is it bad? You do not know. So given the trend that we try to polish things and make things easier, is this really higher education? That's a question I'm asking myself more and more often. It has to be harder. It cannot be so simple as it is in typical presentations. We have to make it harder, but in an effective and meaningful way. For instance, what I can think of is to have a different sort of quizzes. For instance, we can ask about, here's a number of diagrams. Which diagram would provide a sort of explanation? Look at this model that we described so far. Is there any shortcoming? Does it cover all of the effects that are imaginable? Do we cover all special cases when we do proof by diagram? Could we generalize this? Stuff like that. So I would hope that, for instance, a different sort of quizzes could help to go in the direction of higher education. And where I put work, you've seen that, hopefully, I do not put work into production value. The videos that I do are not polished. These are live recordings with ugly writing, really ugly handwriting, but that's okay. Still, there are thousands of viewers for these videos. And look at what Khan does, same for him. And he's capturing millions of eyes. What I think where work is valuable is finding good explanations. That's a really tough job. This may take years. In the foundational course on mathematics, I have still some gaps where I need better explanations. Still looking for better explanations after years. And the hardest part, this is what I learned with the Udacity MOOC, the hardest part is make users think without losing them. It's easy to ask something that's hard to answer, but you're going to lose your users when you're doing so. How can we work around that issue? How can we ask hard questions? How can we make our users think without the risk of creating dropouts? I want to close with this quote attributed to Einstein: if you can't explain it simply, you don't understand it well enough. Thanks a lot.